Okay, this is Unit 10, 9-station review solutions video. For each of the following equations, classify the reaction, then balance the equation. Well, let's look at the first reaction. Zinc sulfide plus hydrochloric acid yields zinc chloride plus H2S, hydrogen sulfide. We have a compound here and a compound there, and look what happens. These two things switch. You get zinc chloride. Okay, and then you get hydrogen sulfide. So that's going to be a double replacement reaction. Okay, and let's balance. We've got one zinc on the left, one on the right, one hydrogen on the left, two on the right, one chloride on the left, and two on the right. So if I were to put it 2 right there, I now have 2 hydrogens on the left, 2 chlorides on the left, and 2 hydrogens and 2 chlorides on the right, and my sulfide is 1 on each side, so we're balanced. Next, you have HCl plus zinc yields zinc chloride and hydrogen gas. Okay, so in this case you've got one element, which is zinc. There is no compound here. It's reacting with hydrochloric acid to form a salt, zinc chloride, and hydrogen gas. Okay, so in this case the only thing that switches out is the zinc with the chlorine. Okay, I'm sorry, with the hydrogen, and there is no other anion attached to zinc. Okay, so there's only one switch out here. So that's a single replacement. Single replacement reaction. Okay, one hydrogen here, 2 here, 2 chlorides, and 1 there, and 1 zinc and 1 zinc. So again, if we put a 2 right there, we're balanced. Next, H2 plus O2 yields H2O. Well, this is just 2 elemental gases coming together to form one compound. Okay, there's nothing else attached to these things except themselves. So in that sense, they're elemental. They're in their pure form. 2 elements coming together, and they're going to form this compound. So that's a synthesis reaction. Okay, that's a synthesis reaction. So now we've got 2 hydrogens here, 1 oxygen here, and 2 there. So let's put a 2 in front. We now have 2 oxygens on either side. We've got 4 hydrogens on the right, 2 on the left. So let's put a 2 in front there, and that makes 4 on the left and 4 on the right, and we're balanced. Next, calcium hydroxide plus phosphoric acid yields calcium phosphate and water. Okay, and water. You can rewrite water like this, HOH, to help you better understand what's going on here. Okay, and if you were to look at that, you see that the calcium switches out with the hydrogen, and then this hydrogen switches over here with this hydroxide. Okay, and when that happens, it forms water. So this is in fact a double replacement reaction. That's double replacement. And over here you've got 2 hydroxides, and over here you've got 1 hydroxide. Again, I rewrote water as HOH, hydrogen hydroxide. Okay, just so that we can keep the OH lumped together. Over here we've got 1 phosphate, and here we've got 2, and 3 calciums, and 1. Okay, so it's going to be most helpful to keep these polyatomics lumped together. Okay, we can do a chart if you want. We can do a chart. Let's do a chart. Why not? Oh, you know what? Yeah, we'll do a chart. Okay, left and right. So we've got calcium. We've got hydroxide. We've got hydrogen. Look at that. And we've got phosphate. Okay. If I start with the calcium now, I've got, well, let's do 1 calcium here, 2 hydroxides, 3 hydrogens, and 1 phosphate. And on the right I've got 3 calciums, 2 phosphates. I'm rewriting water like this now, okay? I'm rewriting it like that, so I've got 1 hydrogen and 2 hydroxides, and 1 hydroxide rather. Okay, I'm going to start with my calcium, balance out the calcium, so I'm going to put a 3 there. So now I got 3. That gives me 6 hydroxides. Okay. Then the next thing I'm going to do is balance out the hydroxides over here on the right side. If I put a 6 here, if I put a 6 in front of the H2O, I now have 6 hydroxides here. I've also got 6 hydrogens. Okay. The last thing I'm going to do is I'm going to balance out the PO4s, the phosphates. I've got 2 on this side and 1 on that side. Okay. So if I put a 2 there, I've now got 2 PO4s, and look what happened to the hydrogens. I've got 6. Okay, and I'm balanced. I'm balanced out. Okay. Oh, I wrote OH here. Let me see. Yeah, I've got 6 of those. Okay, I'm balanced out. That is station number 1. Station number 2, same thing. For each of the following questions, classify the reaction, then balance the equation. Okay, in this case, I've got aluminum by itself combining with this compound, and it switches with the iron. The iron and the aluminum switch. Okay, that's a single replacement reaction. Let's go ahead and try to balance. Aluminum, 2 here. I'm sorry, 1 there, 2 here. 3 irons here. And 1 there. But hey, look at this. Aluminum and iron are by themselves. We can always address those later. But the interesting thing to me that jumps out is this oxygen. We've got a 3 and a 4. So the lowest common denominator between 3 and 4 is going to be 12, right? So we're going to have to put a 4 there. We now have 12 oxygens over here. And we've got 4 over here, so we've got to put a 3 in front. So now the oxygens are balanced. Now all we have to do is go back and balance the aluminums and irons. So we've got 8 aluminums on the right side. Let's go ahead and put an 8 here. And on the left side we have 9 irons. So let's go ahead and put a 9 there. Okay, and we're done. Next up, C5H12 liquid plus O2 gas yields CO2 and H2O. Hey, look, hydrocarbon plus oxygen yields carbon dioxide and water. Okay, that is that's a combustion. Do they have it? Oh yeah, there it is. Combustion. Remember, hydrocarbon plus oxygen yields carbon dioxide and water. Always combustion. I've not yet tried to solve this, so I'm going to go ahead and do this with a table. I'll be right back. Okay, here we go. With these combustion reactions, I usually just go in order. Start with the carbons. So I'll put a 5 there. Now my carbons are balanced. I've got 10, 11 oxygens now. And I've got, let's see, oops, that's 2. Sorry, that's a 2 right there. Let's start with that. Let's start with the right number. Okay, 2 on the right side and 12 on the left. So I'll go ahead and put a 6 there. That now gives me 12 hydrogens. And let's count up our oxygens again. 5 times 2 is 10, plus 6 is 16. 16, okay? So to get 16 oxygens, I just need to put an 8 there. And now I've got 16. Okay, so that's how you solve that one. And again, I'll go ahead and transfer those numbers. It's going to be 8, 5, and 6. Done. Okay, next up, H2O2. H2O2 decomposes rather, into water and oxygen. Okay, so notice you started with this compound, it decomposes, it breaks apart into water and oxygen. Okay, and that's of course a decomposition reaction. Okay, this one is always tricky to me because you've got the H2O and the O2 split up. Okay, but if you put a 2 right there, so on the left side you've got 2. Okay, on the right side you've got 2 plus another 2 is 4, and that works out nicely because then all you have to do is put a 2 in front there. Okay, this one's a little tricky. Sometimes it throws people off, myself included. Next up, calcium oxide plus carbon dioxide yields calcium carbonate. This is an interesting one. This also, because the two are joining together here, these two are joining together and nothing is being released. It's not calcium carbonate plus O2 gas. That's not what's happening. Okay, so because these two compounds are coming together, this is actually a synthesis reaction. Okay, this is a synthesis reaction. The reason why is nothing is being replaced over here. There's no O2 being replaced. Okay, so this is a synthesis reaction. And if we were to examine to see if it's balanced or not, let's just count them and see. Calcium 1 and 1, carbon 1 and 1, oxygen 1, 2, 3, and 3. So that's already balanced. There you have it, synthesis reaction. Interesting one. You don't see that too often.